previous video, we had discussed about the basic introduction of isomerism, and we'd also talked about chain isomerism as well as position isomerism. Functional group isomerism is the third type of structural isomers, or rather isomerism. So here they all have the same molecular formula, but they would differ with respect to the functional group, as the name suggests. So ethanol, and so first is alcohols and ethers. So both these molecules have the molecular formula C2H5O, C2H6O. And here, however, it's an alcohol, whereas in this case it's an ether. Similarly, aldehydes and ketones also form functional group isomers. I think that should have been B. Okay, there's an issue with the numbering, but propanol and propen-2-one, both of them are isomers, and they vary with respect to a functional group, so they are functional group isomers. Apart from aldehydes and ketones, unsaturated alcohols and ethers also form functional group isomers with aldehydes and ketones. So the propane-2-ene-1-ol as well as methoxyethane, all of these are functional group isomers of each other. The next one is carboxylic acid and esters. Basically esters are supposed to be a derivative of carboxylic acids, and here one of the CH3 has been shifted to that side, and they both have the same molecular formula. Cyanides and isocyanides, there's only a difference in terms of CN and NC in terms of bonding. So propionitrile and ethyl isocyanide, both of these are functional group isomers of each other because they have a cyanide group in this case and they have a isocyanide group in the second case. The last one is metamerism. Metamerism is shown by functional groups which have two alkyl chains attached to it. So here there is a difference in terms of the number of carbon atoms in each of these alkyl chains. So this is a secondary amine, an ether, an ester, a ketone, and a thioether. All of these functional groups show metamerism. So here are some examples. The first one is an ether. If you see, the number of carbon atoms in this case are 1 on the left and 3 on the right, whereas in the second case you have 2 and 2 carbon atoms on either side of the oxygen atom. Similarly, in the secondary amine we have 3 atoms of carbon, and in this on the right side we have 2 atoms of carbon. Here we have 4 atoms, and here and 1. In case of a thioether, there are 2 plus 2 over here, that is 3 plus 1 in this case. So these have variation in terms of number of carbon atoms on either side of the functional group. With that, we complete structural isomerism. As I said, stereoisomerism will be learnt in detail at a later point.